Hello, Algebra. How are you? So today we are going to look at rules for exponents. This is going to be the first lecture of chapter 5. This is not on a test next week. However, it will be on the next exam, right? Exam 3. So we have to start because we are falling behind, and let's take a look at the lecture. This is going to be all about exponents. Chat is available to ask questions, so hello chat. So we're going to go through the basic rules. So first we are going to say that b to the n, that's what we are looking at. N is known as the exponent, also known as power, and b over here is base. Quick example would be 2 to the 4th power, and the meaning is 2 times 2 times 2 times 2, which is 16. Let's say you can have 3 to the 4th. 3 times 3 times 3 times 3 equals to 81. You can have 9 squared. 9 times 9, 81. Note that this 3 times 3 and 3 times 3 will give you these 9s, right? More examples. Let's say 5 cubed. That's going to be 5 times 5 times 5 is equal to 125. Let's go with, well, 4 squared. That's easy, right? 4 times 4 is 16. 10 to the 4th power is 10 times 10 times 10 times 10, which is equal to 10,000. So what we are seeing here as a pattern is that this number here, which is called the exponent, tells you how many times you get to write the number. When it's 2, you have 2 numbers. When it's 3, you have 3 numbers. And you just multiply them on the side. List of values that we usually memorize is 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and generally 15 squared 225. We generally never use larger values than this. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. We usually don't use anything past those, but we could. I mean, you can always multiply. You can say 5 to the 4 is 5 times 5 times 5 times 5 and figure out what it is. What I'm listing here are just basic values that show up all the time. 2 to the 4th, is 16. 3 to the 4th is 81. Those are usually the ones with the 4th power. And then technically 2 to the 5, 2 to the 6, 2 to the 7, which you always just doubling by 2, which is fairly simple. So exponents simply multiply the same number, and the number of times you would multiply the same number depends on the value of the exponent. Now, we also need to know what is happening with these fractions and negative signs and so on. So let's do negative signs first. Before I talk about negative sign, I will remind you of PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction, right? So we are going to distinguish between two different cases. There is a case of negative 2 cubed, or whatever, negative 2 cubed, and the case of negative 2 cubed. On the top one, parentheses are grouping the negative sign with 2. So negative belongs over here. Let me write that in blood. Negative belongs to 2. Now, in the bottom case, negative belongs to 2 cubed. It's a difference. It's a big difference. The top, you are going to write negative 2 times negative 2 times negative 2 times negative 2. And that is going to work out to be, 3 negative 2s, not 4, 3. That's going to be negative 8. The one below is going to be negative 2 times 2 times 2. And that's going to be negative 8 as well. Now you might say, so what's the big deal? It's the same answer anyway. Yeah, it's the same answer for odd exponents, but it's not the same answer for even exponents. If you have negative 2 to the 4th, you would have to write negative 2 4 times. And that would give you positive 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. But if you have negative 2 to the 4th, then you have this way, and that becomes negative 16. So you have to be very careful whether the negative sign is included in the parenthesis or the negative sign is outside of the parenthesis. Right? That's the difference. And we just need to be a little bit careful as we are computing values. So these two examples are given as examples in the textbook, I believe. But I would like to jump into the homework and just really quick check the type of okay. So let's talk about fractions. And then we have all of the examples that they give us for homework. So if you have a fraction a over b raised to some power n, you will raise each one of the numbers independently. That's the way it's done. So if your fraction is 3/4 squared, you will deal with 3 squared and 4 squared, which is 9 over 16. That's it, right? 9 over 16. If you have, let's say you have 4 over 3 cubed, then that's 4 cubed over 3 cubed is 64 over 27. If you have 1/5 squared, that's 1 squared over 5 squared, which is 1 times 1 is 1 over 25. So for fractions, you're squaring numbers or cubing them, or whatever exponent, you will be working on that one number at a time. Numerator gets squared, denominator gets squared, right? So numerator and denominator, they're separate. You just apply exponent to each one of them. All right, so now we can combine these problems into the problems they are asking us to work out as exercises. So they would like us to compute 3 plus 4 squared over 2. Now this is where PEMDAS. So for PEMDAS, we do exponents first. So 3 plus 16 over 2, because 4 squared is 16. 3 plus 16 divided by 2 is 8. And finally, 3 plus 8 is 11. So 3 plus 8 is 11. Let's say you have 5 minus 2 cubed divided by 4 squared. So what you do is you, by PEMDAS, deal with the parenthesis first. 5 minus 2 is 3. So we have 3 cubed over 4 squared. We can calculate that as 16. 3 cubed is 27, because 3 times 3 times 3. 3 times 3 is 9, times another 3 is 27. 27 over 16. And maybe we can take a look at one of these problems with the negative signs. They have -4 over 2 everything squared. Now this problem can be solved multiple ways. We are going to use the parentheses. We can divide, right? So we have 6 minus, and now -4 divided by 2 is -2, and then a square. Now observe that this negative belongs to 2. So -2 squared is -2 times -2, which is +4. So this turns out to be 6 minus 4, and the answer is 2. So that's one of the ways to do the problem. Or maybe you want to apply the square before you deal with the division. in the parentheses. So negative 4 times negative 4 will be positive 16. Divided by 2 squared is 4. And now 6 minus 16 divided by 4 is 4. You still get 2. You must get the same answer. There is no debate there, right? The answer always has to be 2. Just which way, right, we get to it. So these are the basics of exponents, right? We have a number raised to another number. They're called base and the exponent. Exponent also can be called the power. And the meaning is whatever number is in a base will be multiplied by itself that many times, which is exponent, right? For quick calculation, you probably know most of these values. You memorize values on this purple chart, and then you just go computing. Now, what are the rules of exponents? This is the title of today's lecture, right? Well, the first rule is that when you raise any number to 0, you will get 1 as the answer. So 3 to the 0 is 1, 100 to the 0 is 1, 1/2 to the 0 is 1, right? And so on. These are all examples. So any non-zero real number b raised to a 0, I'll just say for any non-zero number b. So whatever you plug in, it is going to give you that. Even if you are to have more complicated statement raised to the 0, it's still going to give you 1. It's a very convenient rule, right? It's called zero exponent, and you are memorizing that formula. You are going to say a non-zero number raised to 0 gives us 1. The next rule that we look at is the product rule, which states a to m times a to n is a to m plus n. You simply add exponents. Now we can test this with a couple of examples. How about 2 cubed times 2 squared? Well, 2 cubed is 3 2's. And then we have times. And then 2 squared is 2 times 2. I hope that you see that altogether you have 5 of these 2's. Well, that was 3 plus 2, right? And the answer is 2, 4, 8, 16, 32 in either case. So these are your 3 2's, these are your 2 2's, and when you add them, you get your 5 2's that are on the pile. You can do that with x and y values and, variables as well. If you have x to the 6 times x cubed is going to be what? Well, it's going to be x, 6 plus 3 equals to x to the 9, using the rule. Now, if you want to show this, well, over here, you have 6 x's. Over here, you have 3, for a total of 9. So 6 plus 3 is 9. So let's see a couple of more of these examples. How much is 3 to the 4th times 3 to the 6th? Let's go in chat. You can type that in chat. How much is 3 to the 4th times 3 to the 6th? It is, give me the exponent form. Excellent. 3 to the 10. I'm not going to multiply 10 threes. I don't care what the number is. I just want to know that it's 3 to the 10. That's perfect. It's exactly what I needed. How about y to the 6 times y to the 21? Excellent. Y to the 27. Perfect. So you guys are getting this. Excellent, excellent. There is about 30 seconds delay between what I say and the stream. So I have to wait longer for you guys to respond because you need to get the information, then to process it and answer it, right? So we always have like 30 to a minute delay before I get the answers back. All right, now how about this one? This one is going to be a little bit trickier. 3x to the 6 times 4x squared y. This one is really tricky, right? Or maybe not. I don't know. Maybe you guys are experts already. Yes! Nice. 3 times 4 is 12. X to the 6 times x squared. 6 plus 2 is 8. And then y, just one y. So we put one y on a pile. That's it. Here's another one. 2xy cubed times 16x to the 9 y to the 12. So we have to multiply same variables and multiply constants together. So let's see what we get. Two times 16 is 32. Great. 32. X to the 10, because we have 1x here and 9 here, so that's 1 plus 9, which is 10. And then y raised to 15, because 3 plus 12 is 15. Perfect. So that's all we do. We simply add exponents if they have the same base. Now, if you have, let's say you have x squared times y to the 9, then that's just x squared y to the 9. There is nothing that we can do because x and y are different bases. If you carefully look at our formula, A is the same as A. So you must have the same base in order for this to work. All right, next rule. Next rule is power of a power. A raised to m, everything raised to n is a to the m times n. By the way, we have 4 of these rules, so this is rule number 2 out of 4. We already covered the fractions, so after this there is actually one more rule and we're done. So this is the next one, right? And this one has, again, simple way to solve this. X cubed raised to the 6th power is just x to the 18, because 3 times 6. So we have to be very careful. See, x cubed times x to the 6 is x to the 9. X cubed raised to the 6 is when we multiply them and we get 18. Say you have y to the 4th squared. That's going to be y. 4 times 2 is 8. Not to be confused with y to the 4 times y squared is y to the 6. So they are different rules. Different rules. So how much is 2 to the 6th squared? Yes, excellent. 6 times 2? No, 6 times 2 is 12. That was good. 2 to the 12. 2 to the 12. 6 times 2 is 12. Perfect. So we have that rule. That rule is done. The next rule is raising a product to a power. One of my favorites. If you have 2 numbers that are multiplied and raised to a power, you can apply that power to each one of the factors inside the parenthesis. So that's a big rule. In some sense, it reminds us of a distributive rule. It's not called distributive rule, but technically every member of the parenthesis gets the exponent. Now note that members in the parenthesis are multiplied. That's why it says product here. If you have a plus or a minus in between A and B and stuff like that, different rules. Because in that case you are dealing with binomials and polynomials and other things. This is all one term. Maybe I should, let me write that here. One term, it's too close. One term in parentheses. One term in parentheses. So what are the examples? Well, the easy example would be xy cubed, which is x cubed, y cubed. That's an easy example. What else would be a cool example? Maybe, how about 4xy cubed squared? This is also nice, simple example. You get 4 squared, x squared, and y cubed squared. 4 squared is 16, x squared, and then y to the 6, because power of a power gets multiplied, so 3 times 2 is 6. Star this problem tends to show up on the final and multiple choice section, right? What else would be cool? Let's do all of the examples that I give us in the book. 3z squared negative 2x squared cubed 4x squared y cubed raised to the 5th power, and finally negative 2 squared a to the 5 times 3. All right, where are my volunteers? So exponents have to be given to all of the factors inside the parenthesis only. So example number 3, 4 has nothing to do with the 5th power. We are not going to combine them, right? So let's go one by one. 3 squared z squared works out to be 9z squared. The next one over here is negative 2 cubed x squared cubed. The 3rd power is called cube. All right, so negative belongs to number 2. We have 3 negative 2's, so that's going to be negative 8. And we're going to have x to the 2 times 3 is 6. I will write just in case on the side, negative 2 times negative 2 times negative 2 is negative 8. That's your negative 2 cubed. Next problem. Number 4 is not in parentheses, therefore number 4 will not get the 5th exponent. So leave it alone. Now x squared is going to get 5th exponent, and y cubed is also going to get the 5th exponent, because they are in parentheses that are affected by the power of 5. So this becomes 4 x to the 10 y to 15. And finally, we have the last problem. Now, last problem has this evil negative sign here, which I will have to first break off as a special value, -1, times 2 squared, which is 4, and times a to the 5. And then everything is cubed. So now, -1 times 4 is going to be -4a to the 5, everything cubed. So that's -4 cubed, and then a to the 5 cubed. Now, -4 cubed follows the same rule. So that's going to be -64. 4 times 4 is 16. That's 2 4s, right? 4 times 4 is 16. Times the third 4. So 16 times 4 is 64. A to 15, because 5 times 3 is 15. And that will be that rule. The rule number 4 is the one we already covered. We already know that a over b raised to the power n is a to the n over b to the n. We already covered that at the beginning of the lecture, so that we can square 1/3 and get 1 over 9, right? So now we can work out examples. Let's say you have 2x over y cubed. We work on 2x cubed separately, and then there is a y cubed in denominator. So numerator and denominator get the exponent of 3 in this case. So now we have 2 cubed, x cubed over y cubed. 2 cubed is 8, x cubed over y cubed. Now note that this was the rule where you give exponent to each one in parentheses. Hey, that's this rule. These rules all get together into one rule. So for the last couple of minutes, let's take a look at more homework exercises, ones that are similar you're going to find on your homework. So I'm going to write, let's go with 4 exercises, and then give some time for you guys to try them. And then I will fill in. So we have x squared y cubed to the 7th power. We have x over 2 everything raised to the 4th power. We have 3x squared divided by 5y to the 4th, everything raised to the 3, because we can. And let's do one more of these kind of introductory. Well, this one looks bad, but should be able to sort through. Z cubed squared times 5z to the 5. Okay, so I will give you about 2-3 minutes to work some of these out, and then I will work them. All right, let's take a look at the first one. X squared gets a 7. Y cubed gets a 7. So it's x to the 14, y to the 21. So I hope that that made sense. Next one, x to the 4th divided by 2 to the 4th. Now 2 to the 4th is 16, so x to the 4 over 16. All right, now the spicy ones, right? Well, they're spicier. First, we are going to have 3x squared is going to get its own cube, and in the denominator 5y to the 4th is going to get its own cube. Now each member of the parenthesis will get its own cube. So 3 cubed, x squared cubed, 5 cubed, and y to the 4 cubed. That's 27 x to the 6 divided by 125 y to the 12. The last one, z to the 6 times 5z to the 5, which is 5z to 11. So that's that. Just want to make a few quick remarks, and we are done for today. Homework will be opened, obviously, and I will post. I will talk about the exam. So let's first finish this. So one of the things is, if you have x minus y squared, and you multiply that by another x minus y to the 6th power, altogether you have 8 of them. So you are applying the same rule. You are keeping the content of parenthesis as one unit altogether, right? Even though it's 2 terms inside, but when you take a look, you have something squared times something to the 6th power, where something squared times something to the 6th power is something to the 8th power. We don't really care what's in parentheses as long as it is the same. So if I have a minus b cubed divided by a minus b, that will be a minus b squared, because technically when you just have a minus b, that's the same as writing it as a minus b to the 1st power, right? So that's why I have 2 minus 1, which is, sorry, 3 minus 1, which is 2. Also, I just spotted one of the problems in the book, which says xy over z squared, everything raised to 0. Well, it's 1. As long as x, y, and z are not zeros, the answer is 1. And now, I'm just going to, over here, say, remember distribution. If you have x times x plus 3, the answer is, when you multiply each one, x squared plus 3x. If you have 2x times x minus 9, then you have 2x squared minus 18x. So 2x becomes 1 unit that distributes everywhere. The reason why I'm talking about this is that few examples in the textbook are asking you to also work on distribution. So here they have x cubed distributed into 3x minus 5y to the 4th, which would give us 3x to the 4th, because 3 plus 1, minus 5x cubed y to the 4th. We can't combine them because x and y are not the same. And one more, they say x plus y times xy. Now this one is tricky because the order for distribution is backwards. You are used to have this first. Well, luckily multiplication is commutative, so you can put that first and then do your distribution. So x times x is x squared y plus xy squared. So that will be part on distribution. And we are done with rules of exponents. This video will remain on the channel for you to review. We need to talk about, right, please make sure you are checking announcements on Canvas at all times. Group emails, right, which I will be sending with information about the exam and quizzes and all of that stuff, so we can continue this and finish off this class by the end of the semester. I'll stick around in the chat for some time, and I'm just going to turn off the video here, and you can find this video on my channel under Elementary Algebra playlist. So once it's available for me to move it into playlist, I will move it there. So I will see you all next class. When is that? Next class is Tuesday in this case. All right, bye.